We're looking at a redox reaction. So herein we'll start off with identifying the compounds. So we have zinc oxide. Then it's actually also called as zinc white. Let me write that also. Then we have C, that is carbon, Zn, that is zinc, CO, that is carbon monoxide. I think I'll write this. Now let's balance it out. So I'll show you guys. I know it's a repetition. I know you guys know this. ZnC is your reactant. ZnCO is your product. Then we need to write all the atoms. This is 1, 1 and none. So I'm mapping how many atoms are there in each of the compound. None, none and 1. This is 1, none and none. None, 1 and 1. So clearly this is balanced. So technically I should be writing it as ZnO plus carbon in presence of heat will give us Zn plus CO in form of gas. Satisfied? So this is the balanced reaction. Herein, do we get heat? Do you think so? No, this is an example of endothermic reaction. It's an endothermic reaction. Okay, guys. Because it needs heat more than it releases. Again, quite a few examples are overlapping between different categories. It's important for you guys to remember so that it makes sense to use it because you already know it. Does it make sense? Now, most important thing over here, there is going to be change in solid appearance. That's how we get to know that the reaction has happened. So there is change in solid appearance. So since we started off with white, remember zinc white, or it can be yellowish white also. So we have zinc oxide powder that reacts with black carbon. If the reaction goes to completion, we get a gray metallic zinc. Okay, guys. Then, of course, there is what else? Correct. Gas being released. Gas is released. That's one of the indicators. So this, I think that's enough. Then, yeah, when it comes to temperature, there is need of heat. This is endothermic. That's one more. Indirectly, we're telling that we need heat. Does it make sense? Now, let's look at your, zinc being, how do I put it across? Reduced and copper being oxidized. So let's look at that aspect. So let's look at the periodic table once. So zinc is over here. Then we have copper and oxygen, if I'm right. Okay, so look at the atomic number. Valencies, because the valencies are 2s and 4s, it was simple for us to handle it. It was balanced. Electronegativity and first ionization energy, electron affinity. Can you see the nature again? Oxygen plays an important role over here, having such negative electron affinity. It badly wants it. And it releases energy and all of that. Okay, so very first thing is you have ZnO. So ZnO is what? Covalent or ionic bond? Correct. ZnO is ionic bond. Why? ZnO. Can you look at it? So ZNOS ionic bond. And so it needs a very strong reason for it to break. And C is covalent bond, which is non-polar. And when Z forms, that is metallic bond. And CO, let's look at CO. CO, with this indication, it is covalent bond. Polar. Okay, let's move forward. Let's look at the reduction and the oxidation. So why is it reduced? ZnO, herein you have Zn to be, Zn to be positively charged, because O is going to take up the, yes, oxygen is going to take up the electron. It's going to pull it out because of this set of values, right? And once this is before, and we're looking at after. And in after, we are looking at Zn. Zn is neutral. So it went from 2 plus to neutral. So it went from 2 plus to 0 in some manner. So basically, how can this happen? How can this happen? So it has to gain electron for this to happen. Plus 2 means what? It has positive charge, means it has 2 less electron. It went to 0 means what? Plus 2 minus 2 will give us 0, is it not? Plus 2 and minus 2 will give us 0. What does minus 2 mean? This is loss of electron, this is gain of electron. So basically from plus 2 to minus 2, by gaining 2 electrons, it became neutral. And that's why this is reduced. Gaining electron means reduced, is it not? Now let me keep it over there. Then we have oxidized. So let me write before and after. So what is getting oxidized? Copper. Copper, it was neutral. And now when CO comes into picture, what happens? Carbon is bonded with oxygen. So we are looking at C2 and O minus 2. It pulls it out. So it went from went from 0 to plus 2. So basically it lost electron, and this implies it is oxidized. Is it not? So carbon is oxidized. Again, gaining electron means reduction. Losing electron over here is oxidation.